I, Monica Verma, extends warmest welcome to one and all present here. We are on the 5th day. This is the 14th session of this 1 week teachers training program. And we have our guest of speaker for this session, Dr. S.K. Subad Ali from IIT Bhilai with us. I feel much pleasure to invite Dr. S.K. Subad Ali, sir. Good afternoon, sir. Let me take you all through a brief Good
Good
afternoon, sir.
afternoon.
Let me take you all through a brief introduction of Dr. Ali. Dr. S.K. Subed Ali is an assistant professor in Department of Electrical Engineering from Indian Institute of Technology, Bhilai. He completed his graduation in electrical engineering discipline from Burdwan University, post-graduation from West Bengal University, Kolkata, and earned doctoral degree from Indian Institute of Technology, Kharagpur. Dr. Subid Ali's research-oriented career began in November 2012 to August 2016 as postdoctoral research associate in the Department of Computer Engineering, New York University, Abu Dhabi, UAE. He holds 1 year work experience from 2016 to 17 as assistant professor in the Department of Computer Science and Engineering in Indian Institute of Technology, Tirupati. He is with Department of Electrical Engineering and Computer Science in Indian Institute of Technology, Bhilai since December 2072 till date. Dr. Ali's research areas of interest fall in adversarial machine learning, cybersecurity, hardware security and trust, Internet of Things, and smart infrastructure design security. He has taught courses in subject domains of machine learning, computer system, advanced digital circuit, network and system security, computer network, adversarial machine learning, operating system concepts, and computer organization and architecture. Apart from his ongoing research works, he had been guest editor of a special issue in Journal of Hardware and System Security, Springer Publishing. Also, in December 2017, he had been program co-chair at 7th International Conference on Security, Privacy and Applied Cryptography Engineering held in India. Dr. Subid Ali's major research contribution had focused on challenges and issues in designing cryptographic techniques for intelligent system, security design, fault measurement analysis tools, along with security assessment methods. He, along with his scholarly team, has authored 3 book chapters in the domains of hardware security and trustable computing. Without any further delay, I wholeheartedly invite Dr. Subid Ali sir to take over the session and share his immense knowledge with us on training and testing neural network. Please, sir.
Thank you, Monica. It was like indeed huge intro. I mean, like it is not an intro. You just talk about my entire biodata. But thank you for this. Okay. Okay. Let me share my screen. I just connect through 2 devices because that is like most of the time I feel this is useful in Google Meet. Okay. Just 1 minute. Is my screen visible now? Okay, it's visible. Fine. Okay. Stop. Yeah, so I generally use 2 screens because at least in the class I can see like whether my screen is visible. This classroom portals most of the time you'll see like you keep talking and in between you got disconnected or your slide is not moving in the portal, and there is no way student can like actually let you know because most of the time you make them mute and they cannot speak. So this is one of the reasons we use multiple screen. At least we see like, okay, how we are moving ahead. So anyway, thank you all. May I just know like who are the participant here? Like, I mean like their background and all, so that I'll just focus more on that. I mean like I can decide.
सर मल्टीडिसिप्लिनरी है सर. It's all.
Okay, fine, fine. So I will be a bit more into abstract level. Okay. So yeah. So I have been told to talk about neural network, right? And when we talk about neural network, basically in our institute, we focus majorly into the math. But here I'm not going to talk about much on math, a little bit of basic stuff, and then I'll try to give you some example where I can just directly run some deep neural network using Keras, so that you guys can directly use it. And the advantage of machine learning is that like it has got huge amount of resources. For example, I can compare this with my hardware security. Suppose you want to work in hardware security, so there are hardly few books which you can directly go and study about hardware security. There is hardly any free code, online code available, which you can directly use to learn hardware security. That is what uh, the status of hardware security in terms of freely available resources. But you think about machine learning, if you see the GitHub, I would say like 70-80% of the GitHub data now, GitHub codes are about machine learning. Okay. Huge numbers of book available, online free books available, video lectures, thousands of lectures available. You can go and opt anyone and you can get to know. Okay. That is what the advantage, and the disadvantage is whenever the student just look into the online and they'll start with something and then within few weeks they'll totally lost. They will be losing like where to do, what to do, and they'll have no clue because they will be browsing so much. Okay. In that context, my suggestion to my student, whatever you choose, stick into it. Whomever may be the who's whatever may be the video lecture, stick into it, finish it, do the assignments, and then continue with other work. Otherwise he will be always like like hopping around with different concepts. So let us start the machine basics of neural network, right? So you might have already heard of this neural network fundamentals, maybe because this is entire course is about machine learning. So neural network, the term, it's a network of neurons, right? So neuron, we already know in biology, this is a biological term, biological stuff. A neuron, that is part of the smallest unit or cell, we would say, in our nervous system, right? That is connecting our brain to all the individual senses we have in the skin, in our hair, in our eyes. Every senses are connected to our brain through this neurons. And also the neurons is a transmitter, and also it is like a wire, and also it is like a computer processor through which you also process. Okay. So, and how you can process, I can give you a tiny example, and I can tell you like what does it mean by processing by human brain. Okay. So let us move forward. So neuron actually came long back in 1949. Okay. There was a guy who is partially biologist and partially computer guy, and he came up with this nice interesting concept called perceptron. So basically now when we talk about neural networks, so what is our objective here? Throughout this the entire session you will keep hearing about different machine learning models, right? So what is the objective of this machine learning model? Only two objectives. That is, one is the classification, another one the regression. This is the main two processing we also do in our brain. So either classification or regression. So for example, like for example, when we see something, right? So whenever we see something, we need to decide what is that thing. Okay, I look into the laptop and okay, my brain tell me this is a laptop. That is basically a classification. Then I'm appearing in the exam. In the exam, you get the question. So then what you are thinking of, what could be the possible output? That is again a classification. Regression thing is something like when you are predicting something which is not known, predicting like what would be the next value, given a sequence of value, what would be the next value, like a song. Okay, right? So what if you listen to music, you just listen one by one notes, and then suppose you are predicting what could be the next note. Even sometimes we listen to nowadays, like if you keep listening a lot of Hindi songs, so if you just listen to 2-3 stanza, then you can guess what would be the next term in this thing. So that is what the regression part we do. So majorly we do this thing, and combining these two techniques, we came up with lot of like our interpretation, whatever interpretation we are developing, we developed or we can come up with, that is based on this two technique majorly. And they also talk about some cognition science. I don't have much background into that cognition science. Now people are doing a lot of research in that. So yeah, fine. So when we talk, let us focus in this particular lecture majorly in the classification part. So when we talk about classification, that means you have some given input, and now that could have possible n numbers of output, n numbers of possible discrete value, not a continuous value, discrete value. If that is the case, that means what given input, I'm deciding what could be that possible discrete value, say n possible value it could have. So I need to decide precisely exactly what the value could be. And that is what simple classification. So the simplest form of it is a binary classification. Somebody has just given you something, for example, a coin. Now you are telling him precisely what coin is this. Okay. So now somebody has thrown a coin, you are telling him whether it is a head or tail. That is a binary classification. If somebody is giving you a coin and you are telling him which coin is this, 1 rupees coin, 5 rupees coin, 50 paise coin. So that is like n-ary classification. So this is what simple classification technique. And for this classification can also be represented in the form of regression. So as I say, regression is what uh, where you just predict something, given some knowledge, you predict what could be the outcome for given certain parameters, what could be the possible outcome of it. So there are, if you, I don't know, like I did not attend the entire course. So that is why I did not know, but I hope you already know about regression technique. So you can also use regression technique. If you do not know, that is fine also. So just remember, if you have regression technique, you can also use it to do classification. How do you do it? Simply set a threshold. So let us not talk about much on that thing. And let us just see like what does it mean by classification. So suppose you work as a classifier. So now I gave you two data set like this. Okay, some and some paper. I just put some dots, blue dots and black dots, and now I'm telling you, okay, just separate that. So suppose you are a kid, what you will do, you'll simply put a straight line. Okay, you tell me that, okay, this side of the straight line is the black dot and this side of that straight line is the blue dot. Suppose it is this side is the bad guy, police, thieves, and this side are the good guy, like police and all. So you can plot it. So the moment you are able to plot such a line, then that will become your classifier. Okay. If your classifier is able to precisely separate the data, then it is a actual classifier. So here it is a binary classifier. So you could have something n numbers of such data sets, and if you can plot something and clearly segregate all those n different groups, okay, then that would be becoming the n-ary classifier. So now, why I'm telling this, by visually or pen and pencil we can easily do it, right? But nowadays we what is the use of AI? Use of AI is to do everything automatically. Like this, the use of AI is the automation. Okay, so automation means you just give them the data set, AI will plot that line for you. Okay, if AI can plot it, then we can say, okay, it can automatically actually classify this thing. Now I can use some AI concept to actually make a classifier. So now let us see how a single neuron can be used as a classifier. Then we can move further into multi-layer neurons and how you can, I mean, how we train a single neuron, then we'll go into how we train multi-layer neurons and what are the problem we face like that. So now this is some history. This is for the classes. Let us not delve into that because it will eat a lot of time. So I just have a nice example that you're already familiar with. This is an example of getting a credit card, right? So suppose you are a student and you just went to a bank and telling them, okay, I just want a credit card because I do not a lot of financial transaction every year. I need to buy this stuff. My papa send me money and I use it. I don't want to use cash, so I need a credit card. And debit card has got a problem, blah blah thing. You just want to get a credit card. So now what they do, the one side is the manager, the right hand side guy is you, and the left hand side the tie collar guy is a white collar guy is the manager. So what they do, they take your KYC, all the application, including PAN card, and now they will do some internal calculation, right? So what is that calculation? For the calculation, they'll have some parameters, like x1, x2, x3, xd. Okay. So what is this x's? So one of the parameters, say x1, could be your previous loans, right? Whether you have taken some loan before, and what was the kind of status of previous loan, whether you have written all the loans or you have defaulted, and all this information is defined by x1. Okay. Suppose x2 is another parameter that defines like how much money you transact every year, okay, through your different accounts, how much money you do transactions. So this way you have multiple such parameters that will be decided by the bank. Now, a different customer will have different kind of values of this parameter, right? So based on that, what the bank will do, they will set some weightage to this uh, different parameters, and that weightage is defined by some w1, w2, wd, right? So x1 has got some weightage w1. So what that define? So that means, suppose you are a student, so definitely you won't be doing a lot of transaction and a lot of defaulting, right? So because being a student, you're just like a kid, you just grown up a little bit, you are teenage, something like that. So you don't take loans and all. So what they'll do, they know you don't take loans, so that weightage will be very less. Okay, so w0 value will be very less. So that means that parameter is not that significant. So similarly, they'll decide some other parameters, right? So next, what they'll do, they'll sum up. So they'll sum up all these parameters, and they have a threshold. Okay. Now, if your this weighted sum is greater than that threshold, they'll give you the credit card. Fine. They'll say, okay, we just check your background. Okay, all your previous financial transaction, blah blah things are okay. Okay, that is sometimes we also call as credit ratings, right? But credit rating is not exactly like this, but you can just interpret what they do internally. So based on that, they'll give you credit card. Now, fine, it's interesting. If you get a credit card, you're happy. Not getting, then you are not happy. Then you'll go to some other bank and you'll ask it, and different bank will have different formula, right? This weighted sum would be different. They will be putting n numbers of weight. Somebody will be putting d numbers of weight, something like that. So now, so based on that, like you want to just make this thing run in a computer, so you will just write a function, and then you will just first figure out the function, and then based on that you will write a code so that you can directly give the input and evaluate the function, right? That is the general thing we do in C programming, right? So instead of just calculating, I'll just get to know what is the function. So the function would be like this, the example given here. This is like what the weighted sum, and then if you subtract that threshold from the sum, so that means you are getting, whether you are getting a positive or negative. You are getting positive, that means your weighted sum is greater than your threshold. If you are getting negative, that means weighted sum is less than your threshold. So if it is positive, you are supposed to get a credit card. If it is negative, it is not. You are not supposed to get a credit card. This is just a convenient way to represent this thing, right? This is a convenient way. Again, I can just replace the name threshold with some another variable, which is like symbolically almost same with the previous variables, w0. Okay. So now, fine, I have a function. Now I can write C code, and I can just ask the manager, okay, give me the values of W, and then give me values you got from the customer. That is the X values, and I can just run this function, and the output HX will tell me whether he's supposed to get a credit card or not. Okay, so you don't need to calculate this thing manually. So again, you think like, okay, this is again like plus is there, weighted sum is there. I can further simplify this. So eh, again, further simplification would be you take another parameter x0, make it 1. That is not much difference, right? It is same. Okay, if you take it 1, so you can always consider w0 as w0 into 1, right? It is same thing. So now you just, this representation would be much more simple. It looked very simple, like no plus, only just summation of omega I xi. So done. Okay. Now programming may be difficult. If you want to just show this thing to some guy to just show what is your calculation, you just simply show it by four different terms, right? Four, 5 different symbols. So it's pretty simple to show. So, and you wrote a program, it will just, whenever somebody comes, it will give you the parameters, and weighted is already there, weight is already there in the program. So you just evaluate this function, and he will tell you the outcome, okay, whether he's supposed to get the credit card or not. And this is another representation. This is the vector representation, that is the W transpose multiplied by Y X. This is, let us not go into that machine learning math models. So if you, most of the time, if you read books, you will encounter this. So this two expressions are same. The last one and the previous one are same. So forget about that uh, particular expression. So now the next thing is, fine, you just wrote a program and that is like working fine. Now what is the problem with that program? The problem with that program, right? Each time the bank is decided, okay, like I think like whatever W you have chosen, because of that we are not getting quite a good profit. So we should apply a different W values so that I can increase my profit. So each time they want to change it, they want to make some changes, and then you have to change the code, and then this is like a manual stuff, right? So they have to come up with some W based on that previous experience, and that is kind of manual. And how do you get the experience? There must be some guy who will take all this previous data and figure out, okay, fine, so I should put more value to the parameter x3. Okay, if I put more value, then I'll get more profit next year. So this way earlier they used to decide. So now this is like quite a well-known thing, regular programming. So now how we can actually use machine learning, and what is the machine learning part here? So let us first let us understand pictorially what does it mean by that omega omega tx or wtx or this expression. So this expression, how you can represent this expression in the form of pictures. Okay, so in the form of graph, plot, something like that. So let us assume that it is just a two-dimensional space, right? So you have x0 and x1. So you have only two parameters, so two weight, W0 and W1. So that is basically what is you are getting. It is basically a straight line, simple straight line. So what is this straight line do? That is you have just done in the first plot I have shown. So given a data set here, so blue and green one, you are about to plot a straight line which can precisely classify this two data set, right? So suppose the blue one is the guy who are bad guy, who defaulted, who did not return loan, blah blah thing. They have a lot of objections. So bad guy to the bank, okay. And the green are maybe the good guy. They never default. They have a lot of money. They do a lot of transactions, and they give a lot of benefit to the bank. If they take loan, they'll give you, they pay the interest properly. So much good background they have. So now you just want to classify this thing. If you're able to classify, then the credit card concept is quite okay, right? What based on what functionality based on which you give the credit card? The functionality actually decide whether a given guy is, whether he's a good guy or the bad guy in terms of the bank. So how do you decide it? So you have the previous data from the bank, right? Bank have got a track record of previous guys, and based on that, they'll just plot a straight line which can clearly segregate these two data. If it can clearly segregate, then I can take any new x value, right? Any new x value inputs, and then I put it in the functions. If it is greater than zero, that we learn in the school days, right? If it is greater than zero, we are in the left side of the straight line. If it is less than zero, we are in the right hand side of the straight line. So that means what? If I have the straight line with me, then I can able to classify the given input. Okay. First thing, the most important thing, you should have the exact straight line. What does it mean by exact straight line? Which can clearly classify the data set. If you're able to do that, then you are done. Okay, now you just check it whether the value is greater than zero or less than zero. That means you are in the left side or right side. Okay, that is the pictorial representation. Mathematically, it is again same what you have done before. So again, that is what same programming thing, manual thing, simple programming. There is no learning part here. So now, what is the learning part here? So how do I what does it mean by learning here? Okay, so the thing I just told you, given a data set, you just plot a straight line which can clearly just separate the two data sets. so that you can think, okay, I can see, okay, I can plot this one. Okay, so you can see many possible plots, right? That passes through this origin and just divide. So it could be many possible plots. So all of them will separate this black, blue, and green data set. So that is fine. So now, what is the learning part here? So the learning part here is to figure out automatically figure out the value of W. Right here, you are manually plotting. Okay. Previously in the program, the manager were giving you the values of W. Now learning means what? The data set is given. Now you are precisely figuring out what is the value of W. That means what? Automatically your program will plot many straight lines and choose the best straight line, which is separating these two data set in a best possible way. So in this particular example, it will clearly separate the data. Okay, if you are getting any such straight line, so that would be your uh, function you are looking for, right? That actually classifies it. So that would be your classifier. So machine learning means what? You have to learn the W now. So learn the W means you plot different randomly. So in machine learning, what we do, we start with some random plot. Okay, whenever you do machine learning, start with random thing. So randomly you assign. So let us give you some examples. So here again, like you have only four data set in either side. No, four in this side and five pluses in the right hand side. So you randomly plot, and then you plot it, and then you figure out, okay, one guy is misclassified. This particular plus guy, this is misclassified. So now, so how do you get to know you misclassify? Because the data set you have, this is what the data set, right? X1, Y1, X2, Y2. So these are like N means what? Here it is. N means here it is 5 plus 4, 9. So X0 to X8. So you have 9 data set. So this is what the X values, and Y is what? Level, whether it is in the correct direction, whether it is the bad guy or the good guy. That is what the level, right? So now you misclassified means the model you plotted randomly, that actually misclassified means it is showing that this is actually bad guy, but your model is showing it is bad guy, but actually this is a good guy. So now you should tweak the model. So what do you mean by tweak? You can pictorially you can see that this straight line you have to just rotate a bit here, and so that this will be included in the right hand side. Okay. So now this rotation, this rotation is called updating your parameters, right? So randomly you select some parameters, and now updating parameters means what? Now you rotate it, you will get a different straight line. So what is the parameters of straight line? If you see the simple function of straight line, y equal to mx plus m and c value. So you are updating the parameters. So now you are just including this plus to the other side, and then by just shifting a little bit, you are now perfectly classifying, right? So I don't have the the writing pad, otherwise I would plot it and tell you. But you can see this is the very simple picture. So now what is the machine learning here? So machine learning means here I am actually giving the machine learning is giving you the perfect function for you. Okay, the best possible function. That function here is a straight line. Okay, and how do you decide the best possible function? That means based on its parameter, which is the best straight line for you. Best straight line is defined by its parameters, right? M and C, y equal to mx plus c. So now the best straight line is which one? Which is perfectly classifying this thing. So now you got M and you got C, and then that is what the most optimum, that is what your learn model. So that in what you would do in the learning part, you have this x1 y1 data set, you randomly plot. Now whenever you are misclassifying some data, so now you have to shift, you have to rotate your line so that you can properly classify that particular point. Okay, so this way you, when you keep doing this thing, right, until unless you completely classify. Okay, so now when your program will terminate, this is a heuristic, right? This is not deterministic. So when your program will terminate, whenever your data is perfectly classifiable, okay, linearly, we call it linearly classifiable. So if it is linearly classifiable, then your program will terminate. Otherwise, it will keep on rotating, right? So then you have to need a check on it. Okay, so if you want to make it terminate, if you want to get a best possible case, right? So then if you do not have the optima, so then you can look for best possible case. So best possible case is you can decide, okay, if my model is able to classify at least 90% of the data, then I'm happy with that. So then we'll say my model is 90% accurate. So 90% point in that plot is perfectly classified by my straight line. So then my model is 90% accurate. So these are the term. But why I'm telling all those things? Because the moment I go into Keras, you realize that uh, you can't see all this thing in the Keras, right? What you see in the output in TensorFlow Keras, what you see output, you just see that, okay, number of iteration, that is epoch, and accuracy kind of thing. So very bare minimum data, because everything is handled internally. So otherwise, you have to do the coding from scratch. You don't need to use library. If you use library, you cannot. I mean, like, you can see there are ways to see the internal status, but being a general programmer, you won't be able to see all those things. So you have to do a lot of stuff. So anyway, so this is what a basic perceptron. So this particular straight line is called as perceptron. Perceptron means a neuron. So neuron, as I shown you the figure. So what is a neuron? Neuron is simply perform a weighted sum. Okay, they perform weighted sum x1 w1 x2 w2 something like that, and then you'll get the sum, and then there will be a threshold. That threshold will decide the sign whether it is positive or negative. Okay, so if it is positive, then you are done. If it is negative, then you are rejected, something like that. So this output will tell you whether you are positive or negative. So this is the fundamental uh, perceptron. That is the representation of one neuron. Okay, the way they understood the human neuron, it is this. It is just a weighted sum. That means it takes some signal from the input and process it. Processing means something about it will just sum up and figure out the most active signal out of it, and then they'll decide whether to pass that signal to the subsequent neuron or not. So here pass means it is greater than zero. If it is greater than zero, they'll pass the signal. They'll trigger the next neuron. If it is not greater than zero, they will not pass that signal at all. So this is what um, simple perceptron, that is the building block of the neuron. Now let us gradually move into the uh, the the multi-level perceptron. So what is the weak point of simple neuron or perceptron? Single neuron, we call it perceptron. So what is the problem with that, and how people later on overcome this thing? So we'll just try to look into that. So again, this multi-layer perceptron or deep neural network, right? Deep neural network came from neuron, right? So there were issues with one neuron, okay? And then people came up with, what if I use two neuron? And then there were again issues. Then people decided, what if I take three neurons? And then some other mathematician came over and say, what if you use a layer of neurons? Okay, first one layer with multiple neurons. Then they solve some problem and then figure out, okay, there is an optimization issue. This is taking a lot of time. So what if I use two layer? And then they figure out, okay, if I do two layer, then number of neuron per layer should not be huge. Like if you can take bare minimum neuron in one layer and another set of neuron in another layer, so with a very bare minimum neuron, you can actually do a lot of representation. A lot of representation means you can represent a lot of functions. So we have just seen one function in perceptron, right? Weighted sum with activation or a threshold. Okay, so that is one functionality. You have weighted sum plus activation. So that is one functional model, one function. If you use multi-layer perceptron, so you can represent many functions, and people say it, mathematician will tell you that multi-layer neural network can be considered as a universal function. Universal function means it can be of represent any function you want. But that is like hypothetical. Practically, there are a lot of issues with that. Then when you ask practical aspects, they'll say, okay, you can do these, not that kind of. But anyway, we have a lot of stuff now. Matlab, back in to 1990, if you tell, okay, this Terminator movie is going to be reality, nobody would believe. Nobody would tell you. They'll say this is just a sci-fi movie. But now, actually, Terminator kind of robot are becoming reality. If you see Boston Dynamics, just Google for Boston Dynamics and see what kind of robot they actually build. Okay, I mean, like if you can actually do that kind of fighting with them and cannot beat them. They can actually do kung fu karate also. They can kick them, but they won't fall. But back in 90s, Japan, this Honda, they used to build this humanoid. But if you just push them, they'll fall. Okay. But now you not only push them, you kick them, you hit them, they won't fall. They will have such a great balance and they can do jumping, everything you want, they'll do. So that kind of advancement came because of deep neural network, right? So, so yeah, when we talk about artificial neural network, so that means what you have. This is what one neuron we discuss. This is what one neuron we discuss, right? This is what perceptron. So perceptron, what will do? It will have a weighted sum, and you have some activation that will decide your threshold. Okay. And now, what you actually learn? You learn both this threshold and this weight values, right? So both of this you have to learn for a given data set. So basically, in function, what we do in function we already have in school days, whatever function we learn in function, we already have this W's, okay, and we just evaluate, give the input, and then we do the calculation here and get the output and you can write a program like that. But here you have excess, but you do not know exactly what should be the values of W. Okay, so that you have to learn. Okay, so for that you apply some heuristic approach. So we'll discuss something about gradient descents and all. How do they do it? So and right hand side you will have a threshold. Okay, so based on that you make a judgment whether I pass or fail. So that is also called step function, and there are multiple types of step functions there. Okay, so now let us look into one thing. I just told you, right? There was long back in 1949 this particular perceptron was introduced, but then you see like there was a hibernation of neural network throughout another 50 years maybe after that. 50 years it went into hibernation, and this support vector machine that prevails throughout. I mean, that prevails means everywhere the support vector machine was used back in 90s, like weather forecasting, you go any object classification, detection, everywhere they were kind of using this support vector machines and other small, simple techniques, other simple machine learning models. So, and neural network was kind of died. Okay, and that is why I say hibernation. So the reason behind that is neural network requires huge computation. Right, earlier days when we were doing BTech, we had Pentium 2 processor, and Pentium 2 processor with 256 MB of RAM, 256 MB megabyte. Not talking about GB. That much RAM and processing power means that you cannot imagine, right? So we used to have Windows 98, and then each time you do like run 2 3 program, it will hang up. So that kind of resources was not suitable for neural network. Now you imagine you have this GPUs can perform hundreds of thousands of neuron operation parallelly. Okay, so this has got so many core, thousands of core GPU, that is CUDA core, right? So there you can perform individual operations separately, parallelly. So and that would be really useful for processing neural network. Now you can think, okay, that guy was like a big fat guy, has got a lot of power, but people did not have the resources to afford him. Okay, so that is why that guy was sitting idle. But now you have money and all, you can hire that guy, pay him, he'll do really good work. So that is why now it is famous. But they were like some uh, some real technical issues with neural network, with simple perceptron. So perceptron were become really hype in back in 50s, and then again it died. So what was the issues? That is what they call as Minsky controversy. So Minsky controversy is what perceptron is a linear classifier. It is not a non-linear classifier. So now if you take a XOR function, it is a non-linear function kind of. So that means what? You can see this XOR means it's a 4 data points, right? So these 4 data points are not linearly separable. You cannot plot a straight line like, okay, straight line here, I can separate the data. Then if you plot a straight line here, so this red and green will be in the one side, but you can separate this one in one side. But here it is misclassification. Okay, so red will be here. So this is not linearly separable. And that, like, this is what research, and I say, like, I'm a really a religious guy, so I see it other way. Like, God will give you some information, some knowledge from his bounty of knowledge. Okay, then you get it, and then suddenly you will flourish. Okay, so by that time I hope, like, why there were so many great mathematicians back in those days, but nobody came up with this idea, okay, multi-layer perceptron can come. But it came a lot later. Okay, some one guy who came up with multi-layer, and he said, like, it is possible. Okay, let me see, do I have that slide? I have a nice slide that, okay, I used to do in board, actually, just to show that whether you can the other slide. Okay, fine. Actually, this kind of perceptron, that this kind of plot, it is difficult to explain that thing. So what I wanted to say is, like, so uh, uh, so basically what they came up with, the idea was something like this. See, uh, this is what can I use? Can I use two neuron to represent OR gate? Can I use such neuron to represent? Right. So that was the first question raised into people's mind. Okay. Then they realize, okay, I have, say, this is one neuron, right? So now, uh, in by OR gate. Okay. So OR gate means, can't even plot here, so I don't have. So OR gate means what? You have this two inputs, x2. Okay. When any one of this is high, then the output should be high, right? Output should be high. So this should, we call it a neuron, we call it fire. So when both the inputs are high, then the neuron will be fire. Okay. So now, so suppose you said this weight W1, suppose you have.
Sir, you are muted.
Sir, you are not audible, sir.
Ali sir, Ali sir, you are not able to hear you, sir.
Am I audible now?
Yes, sir.
Hello?
Yes, sir. Yes.
Hello? Anyone in the chat can say whether I'm audible?
Yes, sir. You are audible, sir.
Okay, fine, great. Thank you. My other machine got disconnected, so I thought it's my network problem. Okay. So anyway, so what I was talking about, whether using neural network or multiple neuron, or one neuron, you can represent an AND gate, OR gate. So OR gate is pretty simple. So that means if you set 1 and 1, this two weight, and you said that means any one of these two are 1, so it should fire. So what should be the threshold value? The threshold value should be 1. Okay, if you set the threshold value 1 here, so this is x1 plus w1 and x2 plus w. If x1 is 0 and this one 1, so it was 1, so output will be 1. If either one is 1, then output will be 1, weighted sum will be 1, and then threshold you set 1 greater than equal to 1, so it should fire, right? If you want it as a AND gate, then both should be 1. Then the threshold you set should be 2. Okay, it should be greater than equal to 2. That means you already said this one is 1, this one is 1, and if both of them are 1, then this together will become 2, and then only it will pass. So that is what AND gate. Okay, so now people realize, okay, fine, using one perceptron I can make a AND gate, and one perceptron I can make a OR gate. Okay, and similarly I can make a NOT gate. So now what if I use 3 perceptron? Okay, like what is the expression of XOR, right? A B bar plus A bar B, right? So A bar means not, A B bar means you are just performing AND operation with A and B bar. Okay, and then you are again performing OR operation with A bar B. So then people realize, okay, if I can make a AND or NOT gate, then I can make a XOR gate. And then this concept like multi-layer perceptron came. I mean that multi-level neuron came. So then people realize, okay, using multiple neuron, I can actually represent any Boolean expression. Okay, and then there were like lots of research paper come up, and they shown that okay, you can give me any Boolean expression, then I can come up with like n numbers of perceptron in one layer, and I can represent any Boolean function. Okay, and then people realize later on, this is the progress I'm talking about. Later on, people realize, okay, fine. If you take only one layer, then you need really like the upper limit would be infinite to represent any universal function. Okay, so then people say, okay, what if I use two layer, and then they realize if you increase the number of layer, the total number of neuron is drastically reducing. So if you reduce the number of neuron, your processing power will be reduced, right? Resource requirement will be reduced. So that way actually multi-layer deep neural network concept came. Then fine, deep neural network concept came. Now you can represent a function. What about the training part? Then the training part take a lot of time to actually came up with. I mean, initially people were not able to train the deep neural network. This back propagation, forward propagation was, I mean, back propagation was not there. Then back propagation came, and then the whole lot of like optimization technique came on later on. And these are like the huge amount of research, hundreds of thousands of research paper where there people work on. So, but okay, so mathematically, if you think what is a multi-layer perceptron, why it came, so you can see I know perceptron. Now the problem with the perceptron is that it is a non-linear. You cannot represent as a non-linear function, right? So if you make it non-linear, you cannot make it, then there are a lot of bunch of functions that you cannot represent. So one simple example is XOR. So now people thought of, what if I use multiple perceptron, then I can actually represent XOR. So once you solve this thing, then you had a lot of confidence, then I can solve any function. Okay, then you keep on growing number of neuron in one layer and figuring out that lot of function it can include means it can represent. Okay, then you're realizing the more and more complex function I'm going to represent by this new multiple neuron. Okay, so the problem is number of neuron is increasing. If number of neuron increase, so this weighted sum, right, every neuron has to do weighted sum and activation, so that will be increasing. So if you have a unicore environment, so it is a huge problem. Okay, those days unicore environment were there. So then later on they decided, mathematician decided, okay, what if I use one more layer, and then they realized, okay, there is optimum length, okay, based on the function, optimum depth, okay, and that optimum depth defines a bare minimum neuron, okay, it's not infinite, it's a bare minimum. So, and that they can mathematically prove, okay, this is what the upper limit, this is what the lower limit, and then that concept came, and then people also parallelly, we human being, we got another knowledge that is in the hardware, and we came up with GPUs and such a huge processing power. We came up with clusters, data centers, and then you can run thousands of GPUs together, and then you can solve big problem, like this MNIST data set and all. You see like hundreds of thousands of, I mean, there are like there are models where you have billions of parameters. Can you imagine? That can be trained because of you have such a huge data center clusters. So now let us look into the next part. So fine. So what you can see, like if you put lot of neuron together, that the capacity, we call it in machine learning, we call it capacity of the model. Capacity of the model means what are the different function you can represent by these neurons, okay, that will gradually increase. If you increase the number of neuron, that will gradually increase, and also if you increase the number of layer, that is again also increase. And there is activation functions that decide, okay, that actually provide you the non-linearity of the model. If you remove the activation, it is like you can easily get input output mapping, right? So you can directly precisely relate input versus output, but because of the non-linearity, you cannot do this input output mapping exactly one-to-one mapping. That is not possible because of the activation. And because of the activation, we can use neural network as a non-linear function also. And now, like, okay, so yeah, this is again in concept of mathematics. Forget about this non-linearity and all. Let us just look into the different activation function, okay? And there is a lot of math behind it, why we look for different activation functions. And previously we used step function in the regular perceptron, but here we also use it is not only step function, it's a sigmoid function. Sometimes you see tan function, sometimes this one, okay? So there is one very interesting concept. Am I going to talk about this thing? I don't have much time, maybe another. Okay, I have, right? It is, how much time do I have?
Till 145.
Sorry?
145. Till 145.
145. Fine.
Half an hour time you have.
More than half an hour or 40 minutes.
Yes, sir.
So yeah, fine. So yeah, so let us talk about that that the training part. Okay, this is a bit of old slide I have. Let me see. Okay, this is what I need. So yeah, so let me talk about the training part. Okay, so now this is what the activation function. There are multiple types of activations. I just represented 3. There are few more also. I mean, day by day more activation functions are coming, and these activation functions are suitable for some application, not suitable for other applications, something like that. So people are keep proposing, like research is like that only. Some people will take some application and try to figure out what is the best possible, whether he can improve that application in terms of machine learning. So if he's able to improve, and then he'll propose some new mathematical representation. Okay, so activation function is one thing, something similar. So now let me tell you one simple thing. So if you see these activation functions, this is a ReLU, rectifier linear unit. So this is like very linear, right? Gradually decreasing, gradually increasing on the right hand side, gradually decreasing on the left hand side. Here, so these part the inclination is very high, right? So increase and decrease in very high, but if you just cross these particular range, then it will be very slow. If you're coming here, it will be much slow, and then at one point of time there is no changes, right? So where we need this, okay, we need this in terms of differentiation. See, I generally use a lot of slides to talk about this differentiation technique, how we use this differentiation technique to learn actually. But let us quickly switch to gradient descent and let us talk about what does it mean by updating the parameter, right? I also gave you one example of perceptron, simple perceptron, how you train it. So this is again one concept. This like for the GK you can just have it. In other machine learning model, for example, simple perceptron, support vector machines. So what you have to do? You have to do first. You have to have an input, and then you have to extract the feature. Feature means what? What are the important parameter useful for your model, right? Model means you are going to have a function, okay? So what is the most useful functions parameter you need for that function? So that is called extraction of feature, that you have to do it manually, right? Earlier days. But if you have deep neural network, this internal hidden layers, so these are the hidden layers. These layer actually the perform this feature extraction part for you, okay? The more and more hidden layer you have, the more and more feature you extract from the input data, right? But that doesn't mean if you keep on increasing number of features or number of layer, your performance will improve. That depend on the application also. But consider about the object detection. So this is object detection means like you have an image of the dog, and then it should pass through the model, and the model should precisely tell whether it is dog, cat, all this animal. It should classify, right? So now in object detection, because these particular figure has got huge amount of parameters. So how do I define parameters in an image? That means individual pixels, okay? One pixel would be one parameters. So now the bigger image you give, it will have bigger huge parameters, right? So in general we use like simplest object detection neural network model you use, you will be look for like at least 30 cross 30 dimension of the image, right? So 30 cross 30 means it's 900 parameters. Now imagine Google, what Google used to do. They can take your 4K images, okay? They can even take your 4K image and you directly feed it to the model and classify it. But if I take 4K image, can imagine number of parameter would be in billions, okay? So I cannot have that model in my running in my laptop. It's not going to work. So I'll use a small input, okay, tiny image, and then I'll try to do classification. And that is what the biggest drawback of machine learning. If you want to do good research in machine learning, you need a lot of money. You need to buy a lot of I would say hardware resources, and then only you can actually perform a great research. I can tell you our example. So we have been working on since past 2 years on deepfake detection, okay? So we have literally good result with us, okay? Good result that is run on small resources like laptop and workstation, but we cannot validate on the actual big videos, okay? Because for that we need huge resources, and until unless we have that resources we cannot. And for that we are waiting our institute to buy a cluster. Until unless they buy it, we cannot do it, right? There are some national level cluster like Param Sivaya and all where you can actually run your code, but again there is a lot of limitation. But anyway, my point here, so if you have deep neural network, it will actually do one additional thing, that is a feature extraction. And there are multiple ways also you can actually feature extraction and further feature engineering you can do with that neural network by tweaking the model. Anyway, so so when we talk about model, then we need to talk about training. So we said that you can have multi-layer perceptron that can represent any function, okay? But what we do in machine learning, we precisely learn the best possible functions, right? There could be many possible functions. We need to learn the best possible function by considering its parameters. So now for that we need to train it, okay? So train means what? Each time you make a decision, okay, like previously we plot a straight line, that is the decision, and then we check whether this decision is satisfying the entire data set. If it is satisfying entire data set, then I'm done. But if it is not satisfying all the data set, then I have to tweak it, right? Change it, update it. So that is what updation of the parameter we call. So then shall I do it manually one by one? No. So for that we have to use some optimization technique. So one of the optimization technique is the gradient descent we use. Okay. So now here, like, so suppose you have, forget about gradient descent, suppose you have optimization tool. So now you have a friend who can do the optimization for you. Okay. So what you need to tell him then, you need to tell him what is the objective. Okay. So you have a functions, and then you want to minimize that. If you want to minimize that, then you have to tell him what is the objective. So this is what the function, and then you want to get optimize this parameter theta so that f theta will be minimized, right? So this is what your main objective is, minimize the theta, for minimize the f theta for some values of theta. Now, and this has also got some conditions, we call it constraint. So constraint is gi is another function that is known to you, and gi theta should be less than 0. So this way you have multiple such constraint. Okay. So now objective and subjects, you give it to your friend, and your friend is a very good at our algorithms, and he can come up with some optimized algorithm technique and give you the optimum values of this theta. And now you got the optimum values of the theta, and now the function is the optimum function, the best possible function you have. Now you can just simply, now your model is trained because you got the optimum values of the theta. So now the way you are learning, the way you are figuring out this theta automatically is called learning, right? And for that we will be using some optimization technique. So gradient descent, one of the key, right? So for that, whenever you are doing optimization, right? So you said, like, I want the function f theta, I want this function minimum value of f theta. So how do you decide minimum? Okay, minimum is what, based on what? So for that, that is like we call as cost is minimum. So you know in the algorithm, right? So optimization algorithm, or you know this different algorithm technique, divide and conquer, greedy, right? There also we talk about cost. So cost means at each step you minimize the cost, that is optimizing. Okay, the overall operation is optimizing, the parameter is reducing the cost. So we put a cost associated with it. So cost means a cost function. So cost function, say, that is represented as L. So how do I simply say my model has got a cost function? So my model is a function again. So h theta is my model, where theta is the parameter that is previously W's. So now it is theta here. Okay. So and x is the input. So now my model, suppose my model is trained. So now if my model is trained, so whatever output it will be giving, that should be same as the, already I have the label. Label is the, again, the actual output that I already have with my data. So this is what supervised learning. I did not talk about supervised, expecting that you already know all this thing. So my model is a trained model, well-trained model. So whatever output it will give, that should be exactly matching my output corresponding to that x. Okay, if that is a match, then I say my model is well-trained. But how do I train it? Okay, for that I said I'll randomly choose theta, right? I'll choose randomly theta and see for how many data it is correctly matching. Okay, so if it is correctly matching, so I'll set a some value set. That is what I can take some difference between these value and y. So I'll try to minimize that difference, and that could be a function L. So L function could be the difference, direct difference, right? So we call it L2 difference, L1 difference, right? Some sort of difference. People then there are different function. Okay, I mean, based on mathematical calculation, there could be different functions. So L1 functions, it's just directly take the difference. L2 difference, it is just square difference. Okay, so that way you can think of many possible difference, and that also varies with application to application. So now I need, this is what the cost function, that will, in general way you can think of, it can just differentiate in between your model's output and the original output. Original output, you already have the actual output, that is what your training data set. So now what is your objective here? You minimize this thing as minimum as possible. It cannot be most of the time perfect. So perfect means this difference would be 0. overall difference should be 0. That can never happen in big models with like complicated functionalities. That will never happen. So then what I'll try best possible case. Best possible case means I will just minimize this thing as minimum as possible. So I'll tell my friend, okay, you are an optimizer, so you just minimize this thing. Okay, you get some theta for which I'll have minimum value of this thing, this entire thing, entire expression. So that is what my cost functions. So now there are different types of cost function and square laws cost functions, cross entropy function, and there are so many different functions. Okay, don't like don't directly just dwell into like different type of cost function. You just focus on your application and see for your application what are the best possible cost function you need. Okay, what researcher have proposed. Okay, so for that you need to just dig into more detail of your application and see what math behind it, behind that application. If you know the math, then you can look for research paper and what people have suggested, what should be the most suitable cost function for that particular mathematical function, and you just take it, and then you can expect that your model should converge. Converge means it will give you it will be trained and give you good accuracy. But that requires a lot of expertise, right? It is not like you just learn the theory of repairing a car and just learn the theory and somebody has just given you a car and you can repair it. You cannot do it. That requires a lot of experience. So now let us talk about one optimization technique. That is what the gradient descent. Okay, I don't know whether you guys already have done this gradient descent or not. If you have done it, then you can just let me know. I can skip it. Assuming that you don't know, so what we do in the gradient descent. So I'm telling this like uneven surface is my function, all possible functions, right? So assume this uneven surface mean all possible functions. Like you have thetas, right? This theta is the parameter. So if you change theta, so there could be many possible functions, right? So now I give you the example of straight line. If you change the m and c, y equal to mx plus c. If you change m and c, there could be many straight lines. Similarly, if you have theta, so that could be many theta 0 to theta n. So you slightly change theta, so there would be a different function. So suppose this is what the global set, all possible functions. Okay, now which function you choose? Okay, which function is choose? So here the function is based on two parameters, w1 and w2. So based on that, it could be many possible functions. Okay, many possible functions. If you just change this parameter value w1 and w2, many possible functions, and this is what like entire, like you can see the global function. Okay, there could be many possible positions. Okay, so now how do you decide which function I'll choose, what value of w1 and w2 I'll choose? And that should be based on your objective function. What is my objective function? Is my cost function. Okay, so now I will randomly choose some values of w. So in this particular example, some random value is coming here, that is intentionally shown. Okay, intentionally shown that you started with the worst case scenario and the best case scenario is the lowermost one. So it is intentionally shown the worst case scenario. It might be a case that the random value of w and w to choose, that could be directly this one, but the probability of getting this one randomly is like really 1 in billion, right? So this could be many possible point. So now you just landed somewhere in the desert, right? So that mean, okay, you got this parameter value and that is giving you one function. Now you should update the function, change the function. How you change the function? Here it is just pictorial representation. It shows like which direction to go. If you change the direction, you will get different values of w1 and w2, right? So that means just changing the direction and keep on walking, you are trying different values of w1 and w2. Okay, and each time you take a step, so it should not be continuous, right? If you walk, it will be continuous, but if human walk, it is not continuous because we take steps. So that is a discrete. So the moment you take one step, so you are just jumping to different location. Okay, in that location you are getting a different w1 w2. Now you take that w1 w2 and take your cost function, put it there. Your cost function is parameterized by w1 and w2, that is the theta. So theta is nothing but W1, W2 here. Okay. So I'm sorry that this is supposed to be either theta1, theta2, or this should be W1, W. Okay. But yeah, sometimes for making presentation, we take pictures from here and there. So you cannot directly plot this thing, right? I mean, you can plot it using Python, but why to plot? We just take pictures. So yeah, so let us understand this gradient descent. So understanding gradient descent means you take one direction. So people have taken this direction, and some people have taken this direction also, based on that they got different function at different steps. So first, suppose I'm following this direction. So the first step was this one. I took that step, and I'll go to my previous cost function here. I'll put that corresponding W value and see what is my cost, overall cost. So then fine, whatever cost it is. So I'll just try, this is heuristic. I'll try another step. Okay, I'll try another step and check whether my next step is reducing my cost or not. Okay. So if it is reducing my cost, then I'll say, okay, this current step is better than the previous one. Okay. So I'll update my parameters. Okay. So this way you will keep on updating your parameters, theta. Okay, theta. So it is basically theta can be divided into W1 and W2. Okay. So you keep on going, how far you go. Okay, you keep on going, you'll figure out, okay, I'll go into that direction where actually I'm going decent, going down. Okay, so that is why cost is getting reduced. So I should look for that direction where I'm actually going down, not for upward. I should go downward. So it might be a case you came here in this position, that is a local minima. So if you go farther, you will go again upward here. This is another step. So basically you take this one or that one. So you see this is what one minima and this is what one minima. So each time you take a step toward going down, right? That is why it is gradient descent. So now based on that step, you update the parameters, and now you evaluate the cost functions. And if you see like your cost function is less, this is automated, right? It is not like you are physically walking. It is your program. Now program, how will you know you are going decent? So if your cost function is reducing, if it is reducing, then that shows you are descending. So you keep on doing that. At one point of time, you hit a minima, whether it is local minima or global minima. Local minima means some minima which is not the minimum of all, right? So you can hit that, and then you can terminate. Okay, because if you go any farther, it will be increasing. So you will expecting that is what the minima, and you should stop it. So that means generally, if you follow simple gradient descent, so when should you stop? If you see that if you taking further step, it is actually increasing, right? So if it is increasing, that means you should not go. That means you already hit the minima. But there is a possibility it could be a local minima or global minima. For that, people propose many algorithm. One simple technique: you take bigger step, little bit bigger step. So then there is a less chance that you will actually overcome the local minima. You will reach to the global minima. But that has got a lot of issues. So there is a lot of such thing nowadays. You don't need to deal all this thing. Your optimizer will do all this thing for you. Okay. So yeah. So now let us talk about what is like how to train the multi-layer perceptron. So simply multi-layer perceptron, you want to train it, right? So that means what? You set some parameters here in this particular nodes, okay? So that given input and the output, you can judge the cost. Okay. So cost means what? Now you change these parameters, so output should be changing, right? So what is the objective here? These output of the function and the original output, there should be a very minimum difference. The difference should be reduced, right? So for that, what you can do, you take a directly perform the differentiation on this, right? So that means by changing the parameter, whether this output corresponding to the reference output is changing or not. Okay, that you have to decide. So now how do you get to know the changes? Okay, the changes is known in maths, right? Through differentiation. Differential calculus we do. Changing delta W. If changing delta W is reflecting in the f of x. Okay, so f of x is what? Y. So y delta y. If I change a delta W, if there is a delta y, that means my function is differentiable, right? My function is a continuous and differentiable. So if it is differentiable, then I can apply the school days maximum minima concept and figure out the maximum and minimum, right? So that way you can do. But the problem with multi-layer perceptron is that right, this hidden layer is kind of creating barrier. Initially it was creating barrier because this x, by changing x, it will reflect here in this particular row. But how you get to know, okay, whether it is also changing this one, because you have another parameters here, right? So if you have more layers, so more parameters here, so which one to change and how to get to know which change of w is actually changing y. So that was kind of tedious job. People could not came up with any solution. I mean, there were solution. People proposed some research went on, people suggesting something, but the most prominent and the greatest of all is the back propagation. So back propagation, if you understand back propagation, that will actually, back propagation is what you need. What you need is actually, if you want to find the maximum minima, you need one function, right? So where you'll have, say, this entire thing is one function, okay, y equal to fx. If you have one function, then you can check dy by dx, and that will give you differentiation, and then you can find maximum and minima. But this is not one function. This is a composite function, right? Functions of functions. So that was kind of problem for the for earlier days machine learning researchers. So what they do, the moment they realize this is a composite functions, so they use the concept of differentiation on composite functions like this. So it could be f of x is the g of x. G is the hidden layer. Okay. So now if you want to differentiate f of x, then it is like f of f prime of gx and g prime of x. This way, like you do, right? So now, how do I actually figure out the entire differentiation? How will I get? So this is what your g, and this is what the e, u is the input. So you should be able to get f of u, f of z by f of d of z by d of u. You should be precisely get d of z by d of u. So now in order to get that thing, you can actually back propagate. So back propagate means what? This is what z is the output. So if you know y and z, so what would be the differentiation? Dz by dy, right? So now if it is x and z, so you can say that these two layer you can use dy by dx, and then dy, if you know, dy already know, so dy can be this two can be represented as dz by dx, right? So similarly dz by dfw can be represented dx by dw can be represented dz by dw. So this is very simple. So what is actually I'm doing each time I'm considering this triangle. So dz by dx means what? Dz by dy, dy by dx. Similarly, I can do dz by dw also. I start from this side and keep growing in this side. So now if I keep doing like that, so what I can figure out, dz, that is this one, this is what the output, and u is the input. Now I can actually directly differentiate the entire function, okay, by telling dz by du, right? And this is what you keep on propagating backward. Okay, so first you optimize this one and then keep propagating the parameter information to backward. Okay, and then you can actually, this way you can actually optimize or differentiate all the parameters and figure out the optimum value or the minimum or maximum. So this is what the basic chain rule they applied and come up with a back propagation technique. And then they saw, okay, now, okay, even if you have multiple layer, then I can consider this is as a composite function, and the entire function will be one function, and I can differentiate that. If I can differentiate that, then I can actually apply minima. So if you can, why do you need differentiation? You need differentiation because if you change the parameter, it should reflect at the output, right? If it is reflected at the output, then only you can judge whether you are improving or deproving. So if you are able to do that, then you can improve. There is option of optimizing. If you can't see the changes in the output, then it is not doable. So people came up with this chain rule and figure out that, okay, this is what the back propagation technique you apply, and if you apply it, then you change one parameter and you change that, you see the changes in the output by following this rule. So, and then this gradient descent they apply, and then they come up with solution. So now, fine. What else? There are a lot many more things to deal with. So basically, to conclude for this part, I have another like 10 minutes. So I'll just show you one code to give you, but we will hardly be able to relate that code with my slides. Okay, but I'll just try to elaborate as much as possible. So basically, even if you have hidden real, you can consider that this as a composite function, and you can apply chain rule, and you can perform the differentiation. If you're able to do differentiation, then fine, you can optimize. That is optimization. Then you can apply gradient descent, and apply gradient descent means what? Each step you have to do differentiation, right? So that you'll judge you are going down or going up. So, and now people have shown you can apply back propagation, and then you can do differentiation. Now I can use this multi-layer perceptron, and I can apply gradient descent and optimize it. So fine. So now people have done it. Now people already knew that this multi-layer perceptron is like kind of universal function. Now you have the resources. Now you know how to train it. Now just train it and solve all the problem of human beings. Now people can use it as object detection. People use as a data creation, like a GAN, right? Generative adversarial network. They create data for you, and a lot of many more things. So okay, let me just take you to one of the example. Okay, so one thing I forget to mention. Okay, many of you guys are newcomers, right? So for the newcomers, this is what one of the best book I always suggest to my student. This is a very simple book. Machine learning has got a lot of variety, and you see variety of books. But you engineers, what do you need? You have an application, and then you have to apply machine learning to that application and improve it. That is what would be your basic job in whatever company you join. So you're not going to do research, right? Until unless you don't want to do research, you don't need to dig into a lot of mathematics. If you dig into, then you'll be lost, because machine learning is an interdisciplinary. The math you will see there, it is also interdisciplinary. People apply so many. The ReLU I shown you, the ReLU that came from communication theory, right? So there are a lot of math. They take it from different backgrounds. So don't try to go into the maths. Just start from application only. For the beginners, it's application. And this book has got nice, nicely explained. It will explain in terms of scikit, and then it also has TensorFlow keras, and then you can use these scikit. TensorFlow is a different library, right? That library using which you can actually represent neural network and train the model. So you just need to choose one library and follow what are the different models are there, how to train it, what are the pros and cons, and this book explain. Okay, and this book has got nice code available. Okay, if you go to their site, they'll give you the code for all the chapters. So I've taken one such code, and that is called chapter 10 neural network. You can just take that chapter, and then you will have the code. Go to that source code, and to that chapter 10 you will get this code. And now I'm using Colab. So Colab is kind of like free resources for people like us who do not have GPU based systems. So now you can run your code up to certain extent. They'll give you around 12 hours, I think. So so you can run your code there. So if you need more, then you can buy. Okay, so but we generally don't need to do that until unless you are solving very big problem. So now let us see like what application we are dealing with. So we have taken application here, that is the MNIST fashion dataset. So what is the fashion dataset? So somebody has given you images of clothes, right? Clothes, right? And this code has got a lot of things. I'm not going to talk about all those, but I'll just show you. Just let me run. These are the basic parameters based on which you'll just get to know what are the versions of this sklearn, and the TensorFlow, all this thing. So let me just run it. You don't need to bother all this thing, and what I'm going to use is plot and numpy. So just let me just run it. So this is what Jupyter Notebook. Okay, so the advantage of Jupyter Notebook is that you can make a document also and make a code also. Simultaneously, document and code exist side by side. Okay, and it is also related to LaTeX. Those who know LaTeX, they can directly apply LaTeX formula and make a document out of it. So fine. So, and where should I go? I should directly go to the first, start with the data set. So what data set I have? So I have taken fashion, MNIST fashion data set. So now how do I get the data set? So this Keras is a library, right? So they have some repository somewhere, right? In some server. So they maintain their library there, okay, and you have to include those library, and they have some database also. Some database means some data available there. So one of the data set is the MNIST data set available. So I need to just include those data sets. So let us first, so here we are going to use TensorFlow. So we just use include TensorFlow like this. Okay, you want to check the version. This is most important. Like this version compatibility is a big issue in machine learning. Sometimes you'll get a code in machine learning. While you are running that code, you'll figure out that the TensorFlow they use is a backward, and basic TensorFlow library is not backward compatible. That means what? You take, now I'm using 2.5 version, right? So now if my code is actually using 2.3, that code won't be running in this particular 2.5 TensorFlow version. Okay, so that is why I always need to check the version of this TensorFlow. Now I can directly just take the MNIST dataset from the library like this. So this is from the Keras dataset. If I just run it, so that data is getting downloaded in my local repository associated with this Google account in the Colab. Okay, so now I have that MNIST fashion dataset, and now I take the dataset, I divide it into two sets. One is the training data and one is the testing data. So I did not talk about all these things, right? So in machine learning, you train on model. So fine, how do you train? You train based on the cost function, as I discussed. The L was the cost function. You train it, and you, so the error you get during the training phase, that is what the difference will never be zero. The cost will never be zero, right? Whatever cost you are getting, overall cost, that is what the error. So that is called as training error, and this error is very specific to your training data set. Okay, so but you, specific to training data set means what? Suppose, so we have two parties here in the national level, two parties, right? One is the Congress, another one is the BJP. So now say I am a news channel guy, I want to survey, like in this particular region, which party will be getting major vote. So what I'm supposed to do, I'll take samples, right, from that regions. Now if I take samples precisely from BJP dominated area, so my model will be biased. If I take sample from Congress dominated area, so my model again biased towards Congress. So this biasness will be there. So in order to overcome this biasness, so the same biasness will be there in terms of training data. So in order to overcome it, that means what we have to make it generalized. So we have to make it generalized, means sampling should be more generalized. So for that, what you are supposed to do, we'll also have some other data set. So we will be validating the trained model with that data set, right? So I find we trained the model, we got the function, we got the actual function with the parameter we want, and now we again validate this data set where we call it test data set. So we are just testing it. This is not validation, this is a testing part. So the error will be getting, that is called test error. So we will be, if you are getting minimum test error, okay, then you can say it is like a bit general model. Okay, so not general model, it is more like suitable to unknown data. Okay, so you can further generalize it by considering validation set. So now first we will split the data into testing and training. So this data set will be used to train your model, getting the parameters. Once you get the parameter model ready, now you judge, okay, fine, this data were not given to him for testing, like for surveying, I did not give them. So now tell me, you got the model, how you are performing with this data. If it is performing well, then my model is fine. So now these are something like, if you want to check what are the type of data, how many data are there, configuration, all these things, fine. So one thing we generally do, it's like we convert the data. See here, what is the data? That data is the image, right? So 24 cross 28 cross 28 pixels size. This is a tiny image, very tiny image. See, within this size it is getting faded, so it is so small image, 28 pixel cross 28 pixel. So now fine, you just reduce it to 0 to 1. Okay, so that is again convenient for your model. So, and if you want to see the data, what are the data? So this is one of the example. You can just change this thing to 1. You can see it. What is the data there in 1? And this is some other dress, something like that. And then this is what the classes. The classes would be, there would be 10 classes. I was talking about classes, right, in the first slide. So there will be 10 classes. What does it mean? 10 different types of clothes are there. Okay. And then the label of the cloth, the name of the cloth. Okay, different name of the cloth. Now you got the label. See, this is like Wi-Fi. So Wi-Fi, what is the name of Y4? So you can just press it and it will. Okay, I think I missed this one. Now I should do it. So the 4 is nothing but ankle boot. Some boot is there. So now, so this is what validation data. Anyways, this is what validation data, and this is what test data. And now if you want to print all this thing, you just follow. You guys are programmer, right? You know what does it mean by printing. So you just plot all the data of different varieties. So now let us come to the model. Okay, what is the model? So model means what? It is a multi-layer perceptron. So how many hidden layer? What is the input? How many hidden layer will be there? So that I have to define in the model. So this is how you define model in Keras. Keras dot model dot sequential, and then you instantiate it. So model. So now in the model you add layers. So this is what you are adding, the input layer. Input is 24, 28 cross 20. This is just like you are telling you what are the data set I have. Actual input is this one. Yeah, okay, that is 28 cross 28, and this is what the first your hidden layer, right? Dense layer, that is what we call. And the second hidden layer, and this is what the final output. Okay, so it has got 2 hidden layer. So now just let us instantiate. Okay, you can have n numbers of hidden layers, n numbers of input, n numbers of perceptron. So this 300 means in that layer, hidden layer, you have 3 perceptron, 300 perceptron. And this layer you have 100 perceptron, and keep on reducing, and then you have 10 outputs. This is just output layer. You have 10 outputs. And this ReLU is what? Activation function. In the first hidden layer you are using ReLU activation, second hidden layer you are using ReLU, and the last one softmax. Softmax is generally used for classification, right? From probability to classes conversion is done by softmax. So you can just Google. I did not have time to go through all this. So now, this means you just randomizing the session by putting, instead of going randomize, you just set the fixed value by putting the seed. So now I have this model, and let's run this. This is just showing what model. If you have the model, you can see the layer, and you can also see the summary. It will tell you what are the different parameters in each layer. Parameters, then that is the W things. Yeah, and you can see all this thing. So now let us go to the training part. Okay, these are the different way you can extract different information. Bias information you can extract, and save information. Let us go to the training part. So for the training, what we'll do, model.fit training data we are giving, and the validation data. Okay, even you can train without validation data. So if you give validation data, so you are also parallelly performing generalization. So generalization means you are training and then also validating the training and seeing the validation accuracy, right? So now I can train it, just click it. Okay, I missed something here. Maybe, what is the event? Runtime traced by most extreme. Okay, I forget to include some. data variable here. Let us just click from the beginning. Okay, maybe this one. No, that is the same. So I'm not that good programmer in Keras or TensorFlow. I learned through scratch, matlab, that fundamental coding, writing the neural network code directly using uh, your optimization technique. This is not at all required. I just need to search. See, this is also not required here. Yeah, this is one important compilation. So compilation, while you're doing compilation, that time you're precisely telling, okay, bhai, I'm using this particular model, neural network model, okay, and I'm using, this is what optimization technique, SGT. This is kind of gradient descent, we call it stochastic gradient descent, and my matrix of accuracy is this one, and the cost function I'm using, this is what the cost function I'm using. This is one kind of cost function. So fine, now it should get trained. Yeah, so this is the first epoch running. So this is the first iteration taking the first data set, and by that it's taking the first step and then deciding what is the accuracy. So gradient descent has taken the first step here, and you see the accuracy, the loss in terms of all the data set is 0.7. That's a huge loss. So that is also defining accuracy. So validation loss is like you tried with test data, and now here we are trying with validation data. So basically your validation accuracy will keep on growing. I mean, 1 means 100% accurate, right? And less means it's less accurate. So 0.3 loss should be reducing. The less loss means more accurate. Okay. So because it is very tiny data set, so you will get very huge accuracy here. So maybe around 0.9. You see it's almost close to 0.9. So that means, okay, fine, your model is getting trained. You tried it for 30 epochs. So 30 epoch means what? In that particular gradient descent picture, you have taken 30 steps with all your data set. In each step, you are trying with all the data set and finding out the cost, okay, whether you are in the right direction or wrong direction. Okay, if your cost is high, that means you are in wrong direction, so you should again go in a different direction. So which direction you go? So that is, I forgot to mention which direction you're supposed to go. That is toward the direction of the gradient. If you go towards the direction of gradient, that would be the steepest descent. Okay, so anyway, it was a very short time. So fine, this is what, like you see, it's close to 9.5 or 9.2. It will come up eventually. So let us finish this. Okay, done. So finally, it is almost like training accuracy is 0.91 and validation accuracy is 0.8. So now fine. So now I got my parameters. So if I just click here, if you just see the history, and you'll get to know like what are the epoch you run, and this is what history of parameters. 30 epoch. This is like hyperparameter. It's talking about how many steps you are taking and on. Now, what just happened, right? What just happened is that now I have a model. This model, MODEL model, is trained. It has got all its parameters. Now I can give it X and it can give me Y, and I can give X and I can give him Y and see the accuracy also, right? So this is what evaluate. You are checking the accuracy, right? So here it is showing like it is 0.8% accuracy. Accuracy is like almost 88%, right? It's correctly give you the level it given you. It is 88% correct with this particular given level. Now you want to predict. Predict means what? Now take a unknown data, you got a completely new X, okay, and feed it to him. It will tell you what is the output, what could be the probable output. You can also get what is the probable output. You see, this is what it's like. What is it? The round, yeah. Predict the class. If you want to predict it, it will tell you what is its class. But yeah, here I'm using this is some old library. Okay, you can go to the book site and you can get the latest source code. And basically what this tell you, the new data set, your model is trained and you just predict the class. This is the classification problem, right? This is a data set you are using, that is for classification. Given an image of some cloth, it will just classify. So it should precisely classify, but because of some version issue, I'm getting that error. I'm not, this particular function is pretty old. Okay, so this is what the things are. I think like I'm done here. Hello, am I audible?
Yes, sir.
Yeah, actually, the other side is keep silent, right? And I'm on the other screen, so I do not know like whether I disconnected or not. Yeah, so that's all my side. If there is any question, if you have time, okay. I think I take more than the allotted time.
So participants, do you have any questions? Please ask.
Hello. Hello. Good afternoon, sir. My question is, in a gradient descent, we have the problem of vanishing gradient or exploring gradient. Can we go with the Adam optimizer because of the momentum flexibility of there? What do you say about these things? And can chain rule the problem solver for this situation?
Can you repeat your question?
In a gradient descent, hello, yeah, we have the problem of vanishing gradient problem and exploring gradient problem in a gradient descent. So, can we go with Adam optimizer because there are a situation where we have momentum facility in an Adam optimizer, or maybe a chain rule is a solution of the gradient descent, this kind of problem of vanishing gradient problem.
See this, yeah, I did not deal much with this vanishing gradient descent. The application kind of I encounter that doesn't involve with this vanishing gradient descent. So generally, vanishing gradient descent encounter when your depth is really, your neural network grown really high, like its depth is really high.
When we go for back propagation weight adjusted, then there is a very small values can say which are a very vanishing kind of value. In terms of the weight.
I understand your problem. Yeah. So see, you do this back propagation, right? So you train with the last layer and gradually coming back. So now keep on going back, so this delta is keep on reducing and it will become such a tiny, it is very difficult to distinguish, right, and differentiate. So that is what the vanishing gradient descent. So people see the kind of application I encounter, say for example object detection. So object detection, in that case what they do, it has got a nice name. So basically what we do, we actually another feeding network we use. So we feed the input to in the intermediate layer. So that is called residual network. Okay. So in the residual network, what will happen? So actual concept is this: in between you can think of, okay, I have multiple layers. So people started from the beginning and keep on going the last, and in between it lost what I started with. What means the identity of the identity I have lost in between. Okay, so now if you consider some way to preserve the identity, then you can again, like it's like a signal processing. Okay, I can use a repeater in between, and then I generate the signal again in the same label. So then from that place onward, I'm again like starting afresh. So for that, people actually propose residual network. So residual network, what they do, for example, object detection. You are giving the image of the object and performing all this neural network, deep neural network. So now what they do, what they say, okay, what if I just feed the input to one of the middle layer? Okay, so feeding means just like in that you are just inputting in one of the middle layer. So that means in that particular layer it is kind of signal refreshment happening. So identity again preserve, and they use they have shown that this actually improve this one solution to overcome this vanishing gradient descent issue. Okay,
Yeah, yeah.
but that is
Yes,
one
yes,
solution. There are many other such solutions, so we have to just look into the literature. These are the really advanced topic.
oh, oh. Can we go for optimize Adam optimizer in over the gradient descent?
I don't precisely know. I mean, because I do not deal with this thing. So I know the concept, but I precisely do not know whether it is happening, will be useful or not, because I don't deal with that particular application. Okay, and I also
Okay.
don't deal with that vanishing gradients in terms of theory and all. That is like comes in the deep neural network topic. So, matlab I don't have the answer.
So
Okay, yeah,
Okay.
I don't have the
when
answer.
we will discuss,
Okay.
we will
Okay.
later
Okay.
discuss on deep
Yeah,
neural
yeah,
networks. Then we will discuss on vanishing gradient.
Okay.
yeah.
Okay. Thanks.
Thank you
Okay.
very much, sir. Thank you so much. So I will request Monica Verma ma'am to please conclude the session.
Thank you, sir. It was very keen explanation. The way you deliver each and every topic slowly and deeply with example, it was very easy for other discipline faculty members also to understand the core concept of neural network. We are very grateful to you, sir, for giving your valuable time to us on Sunday and giving
Yeah.
an excellent coverage to the perceptron training and testing of multi-layer perceptron and how back propagation solves the problem which multi-layer perceptron doesn't solve. And the book that you told, we would definitely refer it for further research. Thank you, sir, for enlightening us with your immense knowledge.
Thank you so much again for inviting me. Thank you.
Thank you so much, sir, for coming and giving your valuable time and valuable knowledge to all of us. So thank you so much. Uh, so today's session has been completed. So now we will move to the next session at 3 p.m. and I will request all the participants to be there before uh, at least around 2:50 p.m. After their lunch. So the session 15 will be, the topic will be model evaluation improvement, cross validation in scikit-learn, stratified k-fold cross validation, evaluation metrics and scoring. And the speaker will be Dr. Sridhar Swaminathan, Bennett University, Noida. So thank you again, all the participants. Thank you. Uh, I again thank the resource person. Thank you so much, all of you. So we are signing out for now. We will meet at 2:55 p.m. Thank you.